So, what if true and false just weren't enough? Today, we are diving into a really simple but incredibly powerful idea from logic. It's an idea that adds a kind of truth tag to everything, and it completely changes how we reason. It's called the signed formula. Okay, let's get right into it. We're going to start our journey in a place that probably feels pretty familiar, a world that's strictly black and white. This is the home turf of classical logic. But as we're about to see, that beautiful simplicity, well, it has its limits. You can think of classical logic like a simple light switch, right? A statement is either on, which is true, or it's off, which is false. That's it. This two-option system has a name. It's called bivalence. But we all know the real world is a lot more like a complex dial with all sorts of degrees of truth. And that's exactly where many valued logic comes in, giving us the tools to handle all that nuance. And this, right here, is the central challenge. It's the big question. If we're going to accept that reality has all these shades of gray, how on earth do we build a rigorous, formal proof system that can actually handle that messiness? How do you reason reliably when things aren't just a simple true or false?
Well, let's get to the solution. And honestly, it is an incredibly elegant one that logicians came up with. They basically forged a new tool, one designed specifically for this new kind of logic, the signed formula.
Now, it sounds almost too simple, I know, but this definition, it's the bedrock for everything else we're going to talk about. A signed formula isn't just a statement on its own. It's a package deal. You've got the formula itself, and it's bundled together with its specific truth value. Probably the easiest way to wrap your head around this is the truth tag analogy. Imagine you're literally attaching the truth value directly to the formula, kind of like a price tag on an item. By doing that, we're making truth an internal part of the statement itself, not just some external label we talk about. And that is a huge shift in perspective. Okay, so we've got this powerful new tool in our toolkit, but what do we actually do with it? Let's take a look at how logicians put these signs to work inside their formal proof systems. Their main job is to basically be the engine for these really powerful proof systems that break down complex arguments step by step. A fantastic example of this is something called the Tableau method, which you can almost picture as a tree of possibilities. We explore every single logical branch to see if we can find any contradictions. The whole Tableau method really just boils down to a three-step process. First, you start by assigning a sign to whatever statement you're working with. You tag it with a truth value. From there, you apply these very specific logical rules based on that sign, and that's what creates all the branching possibilities. And finally, you just follow each branch to its logical conclusion, looking for any contradictions that will close off that line of reasoning. And now we get to the part where things get really, really impressive. You see, the true genius of signed formulas is just how flexible they are. It's one fundamental tool that can be used to build and navigate a ton of different logical worlds. And this is just incredibly efficient. Think about it. Logicians can design one single unified set of rules for their proofs, and the only thing they need to change to analyze a completely different logical system is which signs they assign to the formulas at the very beginning. It's like having one engine that can power all sorts of different journeys. This is where it gets kind of mind-bending. Imagine having to keep track of two kinds of truth at the same time. First, you've got what is actually true about the world. Let's call this world truth. But then you have what we know to be true. We'll call that knowledge truth. Some really advanced logics use signed formulas to handle both of these simultaneously, letting us explore that gap between reality and our awareness of it. So this shows us what's called a bifacial proof. It's like you're running two investigations side by side. On one side, you're asking the world truth question, is it real? And on the other, you're asking the knowledge truth question, do we know it? It's a formal way to map out the difference between what is and what we know, all within one unified system. So let's zoom out for a second and look at the bigger picture. What does this incredibly powerful tool actually mean for the entire field of logic? This quote from the source material just perfectly captures the fundamental shift here. Signed formulas take truth from being this abstract idea we talk about, that's the metalinguistic property, and instead they bake it right into the statement's structure. Truth becomes a real, tangible part of the formula, a syntactic component. And the practical payoff here is absolutely huge. We don't have to throw out all the foundational work of classical logic. No way. Instead, this approach lets us generalize and upgrade those core principles so they can work in these much more complex, many-valued worlds. For a perfect example of this, just look at the famous law of the excluded middle. Classically, as you can see over on the left, it just says that any statement A has to be either true or false. There's no middle ground. But now look how it evolves on the right. In a many-valued system, the generalized version says that A must have truth value T1 or T2 or T3 and so on, covering the whole spectrum of possibilities. It's the same core idea, just beautifully upgraded for a whole new context.
So, at the end of the day, what does this idea really unlock for us? Well, it's the power to go way beyond black and white, to let us reason about uncertainty and different degrees of truth. It gives us a way to formally handle logical conflicts, all while building these elegant, uniform proof systems that can adapt to almost any logical world you can dream up. The whole concept of the signed formula proves that even something as fundamental as truth can be re-engineered to handle more complexity. So, the question I want to leave you with is this. If we can do that for truth, what other basic concepts that we just take for granted every day might be ready for a rewrite?